And Clara Rowe. You're not using Wi-Fi, are you? Oh, we're on. Okay. Hello. Good morning. Fantastic morning. Thank you, Richard. Okay. Fenton, Alicia. Hey, James. Hi, Vicky. Benjamin, don't interfere with my YouTube live stream. Where's my coffee? Okay. La 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 la. So we're slowly drifting in here. We got only a few of you. If somebody could post in the group, I'm guessing somebody's done that already, that reminding people in the WhatsApp class chat that this is happening in case they forgot, which happens as well. Meanwhile, before we get started, I just wanted to give high praise to our critical infrastructure workers called Amazon. They brought me new markers. Yay! New markers. Yay! I got a whole bunch. I got 2 boxes. 2 boxes of markers. So that's good for us. And I also, hey Sadie. Hey Konstantin. And I also, for our, hi Yuli, for our learning enjoyment, I got another whiteboard. I've got my standard whiteboard, and now I'm going to have a second whiteboard for graphing. Isn't that cool? We don't graphing anything today, but anyway, so I got that to hang on top of this thing because Amazon drivers are awesome, risking their lives for your educational attainment. So if you're getting some from Amazon, tip your driver. Don't forget, because those people are working hard to make sure, even though we're not supposed to go out, they get stuff to us. So they're awesome. Okay, just taking attendance here quickly to see where we are. Finton is here. I have checked that off. I don't have on my list right now Henrik, Ryan, Carlos, Errol, Sophie, Chris, Felix, Saskia, and Hagen. If any of you are actually here, the people I just mentioned by name, then you can just, Ryan's here, good? So if you can just repeat your hi or say it. It's so early. Well, you know, we only start at 9 rather than 8. Carlos, hi Carlos. Normally we start school at 8, so 9's better, isn't it, Konstantin? 8's very early. 9's not quite as early. Well, anyway, I know it's relatively early. This is the earliest time we've got any of my classes doing their live chats, live streams, whatever. But yeah, it is early. We're supposed to do our live streams during our class time, which is why we're having it at this time. And I know maybe some teachers don't do live streams, or maybe some teachers do live streams or Google Meetups during other times. But anywho, that's the directive from the powers that be, that we're supposed to do these during our class time so they don't interfere. Anywho, so welcome to our last physics class before break. That's right, isn't it? Yeah, our last physics class before break. I did have, I think it's going to be something interesting. Yeah, I know. Yeah, Felix is here. Okay, excellent. Good. So I wanted to talk to you guys more about waves, and specifically what I wanted to talk to you about is the wave speed relationship, how wave speed is related to wave frequency and wavelength. So this is the relationship we want to talk about a little bit. This one. Okay, and just a reminder what those quantities mean. V is the speed of the wave. F is the speed, is the frequency of the wave. And lambda is the wavelength. Okay, so just a reminder about those, what those quantities mean. They're there. And then also, I just want to remind you about the fact that frequency is 1 divided by period. Now, most of the time, we're going to not deal with it. Hi, Hagen. We're not going to deal with it in terms of period. We're going to deal with it in terms of frequency or wavelength. Okay? And on that context, yesterday we talked about sound waves and we talked about light waves. Okay? And for normal conditions, meaning in our atmosphere, the speed of sound is equal to about 343 meters per second. Okay, and then the speed of light is equal to 3 times 10 to the 8 meters per second. Okay, just a reminder about those numbers. Now, how are we going to think about these? We're going to think about these in actually 2 different ways. So, sound waves, generally, we think about sound waves in terms of wavelength or frequency. Which one is it? You can answer in the live chat. You might know this. Sound waves we talk about in terms of frequency, F, or wavelength, lambda. Do you guys know? Keep on going. Who's got it? What do you guys think? All right. Nobody else has an opinion? Ooh, there we go. People are coming out with opinions. Yuri is changing the frequency. Okay. Don't know if he Googled that or just came up with it. Charlotte came out with wavelength. Jacob wavelength. And now we have a bunch of people coming in with frequency. Okay. And Jacob's intimidated by the people rushing in and saying frequency. Now going to change his mind as well. Okay. Good. It is frequency generally. And so you know that because we sometimes we talk about high pitch, for example, high pitch, or a low tone, a low voice, a high pitch. Okay. And what are we talking about there? For a high pitch, we're saying the frequency is great, a big frequency. So for big frequency, we talk about a high pitch sound, okay? And that's how we normally talk about sound waves in terms of their frequency. And you might even be familiar with the fact that the human ear can hear only certain frequencies, okay? Now, what is the lowest frequency? Audible. The lowest audible frequency. How many hertz is that? Do you guys know? Type it in the live chat if you know. What is the lowest audible frequency in hertz, in oscillations per second? What is the lowest frequency? Some of you might have heard this before. Okay, throw it out there if you know. Jacob threw out 200. Yuli's going on the 200 train. He's adding 200 to that. Anybody else want to add? Somebody's Googling it, I'm guessing. Any other guesses? No, even lower. 200 is too high. 20, there you go, Konstantin. Yes, it is about 20 hertz. So the lowest audible range is audible frequency is about 20 hertz. Okay, and how about the highest range? The highest frequency that human ears can hear. And you're doing good, Jacob. It's important to be engaged, and when you're thinking about it, that's good. Maybe you got the wrong answer, but that's okay. Okay, so that means you can still learn something. That's good. So the highest frequency is how much? There you go. Konstantin just looked it up. It's 20,000 hertz, and this is the part where you guys can make fun of me. Well, I guess you can always make fun of me because I'm your physics teacher. But so you can talk about this high number and say, well, Mr. Blessman, 20,000 hertz at your age. I mean, seriously, that's unlikely that you can still hear that high pitch. And you might have heard this before, that when people get older, in their 40s and in their 50s. Oh, Konstantin knew it. I'm so sorry, Konstantin. You are very good physics student, genius, engaged, working hard, doing an awesome job. Okay, so this high frequency, 20,000 hertz, is so high that not many people can hear it, and if you can hear it, it's quite quiet. Okay, so most older people, their hearing cuts out at maybe 10,000 hertz, and it kind of gets lower and lower. Senor, thank you. It gets lower and lower as you get older. So the top range actually goes missing as you get older, and you can't hear those frequencies. But this is a good ballpark range, and that's something also to keep in mind in terms of designing how a CD works or an MP3 works, because if you're designing something to record sound that humans are going to hear, you want to make sure that these frequencies can be heard, and you don't have to record higher frequencies, for example. Okay, so CDs, for example, record up to about 22,000 hertz. That's the limit at the top frequency as to sound that's recordable on CDs. Higher frequencies you can't record. Okay, anywho, so let's get back to our relationship. We had V equals F lambda as our relationship, and we now have a value for frequency. Well, that means we can calculate the associated wavelengths, okay? We have 20 hertz here. Let's find what the wavelength is of that sound wave at just 20 hertz, very low frequency. What is the wavelength of that sound? You'll be surprised, I think. So, how do we find wavelength? I'm going to scooch down a little bit. There we go. So, reminder, this is our relationship here. Okay, and I'm going to squeeze here the Idiotendreieck. Oh, whoop, whoop. V, F, lambda. There's our Idiotendreieck up here. So if we want to find lambda, we just cover up the lambda, and we see it's V over F. Okay, so lambda is equal to 343 meters per second divided by 20 hertz. That's showing up? It is showing up. Seems like it's a little turny thingamajigger. Is it just the angle? Okay, good. So 343 meters per second is the speed of sound at standard temperature and pressure. And we have 20 hertz as the frequency. So what's the wavelength, the longest wavelength of sound? Good job, Jacob. So we go 17.15 meters. I'm just going to leave it at 17 meters. That's fine. 17 meters. That's really long. That's twice the width of a soccer goal, or the size of the line. Okay, hang on, 17 meters. This is probably how long your apartment is. Maybe even shorter. It depends on your size of your house. So 17 meters is pretty big. That's the length of our classroom. Maybe even a little bit longer. Anyway, that's a pretty big thing. 17 meters is pretty long. So that's a long wavelength. Always the same. Wouldn't that mean that the wavelength has to be larger the lower the pitch is? That's correct. Right. Correct, Richard. So 17 meters is the wavelength for a low pitch sound, 20 hertz. Let's now find the wavelength associated with the highest pitch sound that humans can hear. Okay? So this is 17 meters. That's the lowest. And now we're kind of gonna go kind of put quotation marks around, because as Richard just pointed out, that's why tubas sit in the back. Funny. So 17 meters here. I think the tubas sit in the back so they don't block people's view. Okay. Anyway, so let's find the associated wavelength here for 20,000 hertz, and you guys put that in the chat stream. So find it and type it in so I see that you're participating. All right, Yuli and Richard have it. Charlotte got it correctly. Hang on a second. There's a little bit difference there. So we've got the digits are right, but then you have. Yes. Okay. Okay. Watch out, people. Okay. So we have two different answers. I'm just making sure we do this correctly. 20,000 hertz. So what we've got to do is 343 divided by 20,000. Okay. Now this is 1,000 times bigger. So the answer should be 1,000 times smaller than this. And that should be 0.017 meters. Okay. Or normally we don't talk like this. That's one of those important things to remember, how to express answers, because this seems uninformative. If I now call this, though, 1.7 centimeters, that's a better answer. You guys agree? Or we could call it 17 millimeters. That's also a better way of expressing that answer than giving this number in terms of the meters there. So that's kind of the range. So sound waves, for their range, are between 1 or 2 centimeters and about 20 meters. Okay, so that's kind of the range for what we're looking at. So the shortest sound waves we can see, that we can hear, are about that long. Okay, that's the shortest sound waves your ear can hear, about 2 centimeters. And the longest ones are wider than my arm stretch. My arm stretch about 6 feet, maybe about 1.8 meters. So 10 times as far is about the distance for a wavelength of sound that we can hear. So that's the audible range. And just as, I don't know if this is a fun fact or what this is, but pianos, that's still on here. Pianos on a keyboard, a standard piano, ranges from, I looked this up, 27.5 hertz is the lowest frequency that's present. The highest frequency is 4186. Okay, whoop, I'm going to go a little lower here. There we go. So there we go. By the way, these have names. This is A0, and this tone is C8. Okay, so that's the range we have. And one more sound wave I do want to mention to you guys, one that musicians use quite a bit is A4, which is the standard tuning tone that they use for tuning an orchestra, for example. And it's kind of somewhere in the middle. And A4, whoop, am I still on the screen? I am. A4 is 440 hertz. Just about. Okay, so just to give you an idea of what those are, and we're not going to figure out the wavelength right now, but we basically talked about how to find the frequency from the wavelength from the frequency, like for sound waves. Okay, good. No questions? Everybody still with me? Good. All right. So let's go put this away. All right. So, 432. Okay, I might have been wrong. I thought I looked it up correctly, but I might have done it wrong. I'm not a musician, so I might have made a mistake. It's possible. Okay, so how do we talk about light sound? We talked about. So when we talk about light, do we normally talk about light in terms of F or lambda? How do we normally talk about light? Okay, put the answer, how we normally talk about light that we see in the live chat. Is it F or is it lambda? Yeah, it is wavelength, which is kind of very convenient at this point, right? So we talked about sound, and sound is generally expressed in terms of frequency, 20 to 20,000 hertz being the audible range for our ears, well, at least if you're not as old as me. And light, we normally talk about the wavelength in terms of what wavelengths are visible and what wavelengths are non-visible light. Invisible light. Okay, so the visible range, so it is lambda. Visible range. The human eye works from about 380 to 740 nanometers. That's the visible range, 380 to 740 nanometers. That's a little bit tricky to remember. Hi, Sophie. This is a little bit tricky to remember. So, but in general, the way I remember it, and I think it'd be, I don't know. I obviously find a lot of this information handy. So this is the actual range. I remember it as about 400 to 700 nanometers. Okay, and I think it's worth knowing. I'm not sure, but hey, that's what I think. Now, in terms of this range, that corresponds to the visible range, okay, where this is the longest wavelength and this is the shortest wavelength that we have that we can see. Correct. So let's take this first talking about the visible range. Why not 750? Because it's easier to remember one number than two, and it rounds pretty closely to 700. I know it's closer to 750. If you want to remember 380 to 740, that's awesome. I just remember 400 to 700 because that's close enough. And also you can be like, oh, well, it really depends on the individual person because every eye is a little bit different, right? So, okay, so that's the general range, 380 to 740. I remember 400 to 700. That's good enough. Okay, so You guys, being not totally, absolutely American because you live in Germany, you might not have heard of how American wavelengths. They remember them by the first letters of their colors. What is the little ditty that they tell you to remember the colors of the rainbow by in America? I don't know if I spelled that right. Mnemonic device. There we go. Roy G. Biv is correct. Good, good, good. Excellent. Did I spell mnemonic correctly? I'm not even sure. So anyway, mnemonic devices are ways that we remember things. Okay. In German, that's called Eselsbrücke, which means donkey bridge. So easy to use, even a stupid donkey can remember the wavelengths of visible light. So in that sequence, Roy G. Biv, okay, we have all the visible colors in there, starting with, oh, I should do colors. I have them all. That's so cool. Starting over red, orange. Oh, everybody's favorite marker color. Yellow. Green. Blue. Okay, now it gets difficult because the I stands for indigo. Mnemonic? I don't think that's right. I think you're thinking of pneumatic. Like pneumatic, you can't see yellow. Yeah. I'm going to just kind of highlight it a little bit. Yeah. At least you can see the Y for yellow. Yes, you did. I am monkey. It is right. Yay! It's a hard word to spell. Okay, blue. Indigo and violet are kind of similar. It's a little bit difficult. So I'm going to draw indigo here as like blue and purple together. Let's try that. And then for purple, for violet, we're just going to go just with violet. And I'm not sure if that worked, but there we go. There are our colors, indigo through red through violet. Now, why did I do this? Because I wanted to talk about this range and see how this all fits together. Now, red is actually the longest wavelength, so that's about 700 nanometers. Whoopsie, let's go black on that one. And violet is the shortest. And as already pointed out, I think it was Richard, these are the visible range, but we have ones that are beyond that, beyond violet, and we have ones that are below red, under red. Well, above violet, ultraviolet, below red, infrared, and we have also other invisible light, such as X-rays and gamma rays. And on the other side, we also have microwaves And then over here, radio. So the visible range is just part of the entire electromagnetic spectrum, because the invisible light and the visible light together, they're all electromagnetic waves. Okay. And based on having those wavelengths, we could now find the frequencies using our idiot triangle, but we're out of time. So I'm going to stop there. It would be pretty straightforward. You guys are 10th graders after all, to find the wave frequency from the wavelength, because they're connected through the speed, 3 times 10 to the 8 meters per second. But we're going to stop there because I think we had a good introduction to the audible spectrum, the visible spectrum. We have a good way of kind of keeping in mind how to remember these things. And otherwise, we're at the end of this and we're going to say goodbye. Next couple of weeks, we're on spring break, and there's no required assignments during spring break. I think I'm going to offer an optional kind of physics hangout. If people want to get together to ask questions or do some more problems, I think I'm going to do one session a week for 10th grade if you want to stop by and do some work. We're not going to do 9 o'clock. I'll probably schedule these late morning, 11 o'clock or so, or even in the afternoon once a week. And I'll put the 2 10th grades together and offer it to you guys if you want to come by and do some practice problems or just learn some stuff or whatever, then you can do that. Okay. Otherwise, have a great spring break. And we're slated to be together again after spring break in the class room at JFK. We all kind of have a feeling like that might not happen, but we'll see. No announcement's been made yet. So let's plan on being together again on April 20th at school. And if not, I'll see you back online.